Okay, it's 1 minute past 9 o'clock in the morning, and we're out of respect for everybody's time. I'm going to go ahead and start today's session. This session is being recorded. It's October the 8th at 9 o'clock in the morning, and we're here at the South Campus Cisco Lab. And I'm going to demonstrate this last lab, 15.6.2 on Packet Tracer this time, for the benefit of those that may want to do this at home or catch up on any other labs at home. All the chapter module exams are turned on. The final exam is turned on. They will remain turned on until about 5 p.m. next Wednesday, the 14th of October, at which point all work is due by that date, and I've got to turn them into the dean. And this is an 8-week mini-term course, so that'll be our final exam week. It officially started yesterday, it'll end next Wednesday. And then you guys that have signed up for the number 4 course will start again that week following that. We'll come back here again on Tuesdays and Thursdays. I've also got some Cisco 1 people coming in that'll be on Mondays and Wednesdays in the second 8 weeks. Okay, so I'm going to use we're going to do this lab. I'm going to demonstrate this lab for 15.6.2 on static routing. And in the interest of brevity and time on the packet tracer, I'm going to demonstrate the IP version 4 part of this lab where we're rolling. We got microphones. Good. We're rolling. Good. And then you guys here in the lab, physically in the lab, can complete it on the real equipment. And there is a gotcha in that the printed lab refers to the routers as having G0/0/0 and G0/0/1 for their 2 Ethernet ports. And our routers are G0/0, only 2 numbers instead of 3, and G0/1. So if you're doing this in your home lab on real actual older equipment, G0/0, F0/0. If you're doing it in packet tracer, you can choose a Cisco 4321 router, and it will correspond to the lab exactly. Okay, so the first thing I'm going to do is I've got packet tracer on the overhead screen here in the lab, and it's being broadcast as the Blackboard Collaborate recorded presentation. And I'm going to bring a couple of routers into the topology here. So I'm going to click on the router group, equipment group, and I'm going to use the second one here, the 4321 router. It corresponds exactly to what we're doing in today's lab. So I'll drag a couple of those into topology. And so it looks good on the screen. I'm going to go to the config tab. Oh, it's still booting. Fortunately, these packet tracer devices boot up much more quickly than the real devices. The real devices in here take about 3 minutes to do a full boot. The packet tracer devices boot up pretty quickly. So what I want to do is name this as router 1. And he's giving me a conflict here because the other one is already router 1. I'll call it R1. And then I'll go to the second router, and I'll go to the config tab, and I'll call this a display name on the schematic diagram. It'll be R2. And we're supposed to call it just R2. Now he gave me, oops, I fat fingered it. Now we should be able to go back to the first one and make him router 1 because there was an existing router 1. He didn't allow me to do that. Okay, so now our R1s and R2s look good. And they're already been host named as R1 and R2 in the CLI. We'll get that in just a second. But let me go ahead and pull in a couple switches here in the topology. This is going to be eventually be our S1s and S2s. So the 2960 switch, in this particular lab, we could actually replace both these switches with a piece of wire because the switches aren't doing anything. There's no VLANs. This is why it's very important. Rod, you've already taken care of this. Make sure if you're here physically in the lab and you did that switch thing last time, make sure your switches are erased. Have to erase the VLAN.dat if it exists, and it did because we did VLANs. Have to erase the startup configuration. You want those 2 switches to simply be a pass-through. They are going to give us some minimal configuration on the switches, but they're not doing anything other than being a full switch, regular old default configuration switch. Now I'm going to go into increase the size of these. Where is the thing here? Oh, here we go, zoom. Control I. Make them a little bigger so they're a little easier to look at. Because in Blackboard Collaborate, sometimes this packet tracer screen is a little squished up from side to side. Okay, I need to go into the switches and do just the bare config tab and change. I'll do switch 1 first this time because it gave me an error when I tried that last time. So this is switch 2, and his host name will be S2. He'll do that for us. We won't have to do that configuration. And on the first switch, we'll make him switch 1, and we'll make him switch 1. So remember, computer science professors, you ask them to count their fingers, they go 0, 1, 2, 3, 4. So he starts with 0 instead of 1, like normal human beings would do, not us dweeby tech geeks that we guys are. Okay, so switch 1 and switch 2, and let's go ahead and make the physical change connections between them. So I'm going to click on the dark. I clicked on the solid black line. That's a standard Ethernet cable, just a straight through cable. And I'm supposed to connect 0, 0, 0 of the first router to 0, 0, 0 of the second router. That's the core connection between the two routers. The red, they're staying red because they're not going to come up. We haven't done the no shutdown command. They're not going to turn green until we do the no shutdown command. Okay, we're also supposed to link the two switches together with their number 4 interfaces. So fast Ethernet 4 through fast Ethernet 4. Those are amber, like a real switch. If you plug a real wire between two switches, the light would come on immediately as an amber. And spanning tree protocol, after about a little less than a minute, they're going to go green. Because switches ports are by default not administratively shut down. They're ready to go up as soon as you plug a wire into them. They'll just sit there down and down, so you plug up a wire, and then after a second, you'll get the up and up. Now we need to key the connections between the routers and the switches, and this is the standard topology in the newer labs. Is the first Ethernet port goes to port number 5. And the wire is still in place from this last lab. You use the same wire last time. And I'll go from 5 up to gig 1, and we wired up. Okay, good. Okay, I'm on page 3 of the lab now, and we're going to do some basic configuration on the routers. So I'm going to click on the first router and go to the CLI, and I'm going to pull it out a little bit here because it kind of wraps it up there. We already did the R1 when we went to that configuration tab, the GUI tab. He made it R1 for us, so we're going to need to do this. So step 2, little a, has been done for us. And now we're supposed to say no IP domain lookup. Oops, I misspelled it. Okay. I'm going to go down the page and do R1 and then come back and do the R2s. So I'll have to make you guys dizzy and have an epileptic fit with flashing back and forth between all these different screens. So now we're supposed to go enable secret class. So you have to know the void is class to get to the enable mode. Line console 0, password Cisco, and then the login command to enable logins. And then line TY 0 through 4, password Cisco, login. They're kind of scrunchy looking. Let me see if I can make this. Where is the thing for? I know there's a thing in here for making the font a little bit bigger. Okay, so on the CLI, I'm going to make the fonts bigger here and see if it's easier to read. Oh, he took it away from me. He stole my focus. Okay, we'll try again. There we go. All you guys watching remotely or watching the recorded presentation, that's a little bit easier to read. Okay. And then service password encryption. Let me go back to just the regular plain configuration mode. Service password encryption. Nice quick tab completion there. Now I'll repeat all this stuff on R2 so we can finish our page 3. So I'll click on R2, go to the CLI, expand it. And we're supposed to go no IP domain domain lookup. I misspelled it again. Okay. enable class line console 0, password Cisco, login, line VTY 0 through 4, password Cisco, login, and configure terminal, service, password encryption. Okay, so we've completed all the steps on page 2 for routers 1 and 2. I'm going to skip the banner message of the day, but I will go ahead and save the configuration. So copy running configuration to the startup configuration. 2. Copy running configuration to the startup configuration on R1. Now we're going to go to the switches. If I was doing this on the real devices at this point, I would be walking over and swinging cables on our real devices, but on Packet Tracer, it's just a simple matter of clicking on the switch, going to the CLI, make it a little bit bigger. So S1 and S2 have been named for us because we do that in the config tab, in the GUI config tab. So we're going to do some similar stuff on this. No IP, domain, lookup, enable, secret class, line console 0, password Cisco, login, line VTY 0 through 15, password Cisco, login. The switches traditionally have had 16 incoming VTY telnet ports, and their old routers had 5. Actually, the new routers have more than that. You can do more. You can do 16 on the new routers if you want to. Okay, I'm going to go ahead and do the S2, and then we'll flip the page and do them both on the second page. Okay, so S2 has been host named for us. We'll do no IP, domain lookup. Is it going to tell you? He doesn't like it. No IP, domain lookup. Enable secret class, line console 0, password Cisco. He takes it there. Login, line VTY 0 through 15, password Cisco, login. Okay, now I'm going to go to page 5 of my printout. Now I'm already on S2. I'm going to do S2 commands down halfway to that gray bar in the middle of the page, and then I'll come back and I'll jump to S1 and do them. So go back to the pure config prompt here so I can use abbreviations. Service, password encryption. I'm going to skip the banner message of the day. Now in the lab, he wants you to, good practice is to shut down all the ports that aren't being used on the switches. And in this particular lab, only port 4 on both switches are connected to the, his neighbor switch, port 4. Okay, I'm not going to tap that here. I'm going to save a little time. I will go ahead and save the configuration. Copy commands are done from the not privilege executive. Copy, run, start, and then I'll go back to S1 and do those missing commands that we did. So service, oops, got to be in config mode, config T, service, password encryption, and copy, run, start. Now, did I give the host names to the routers? I think I did. I'm going to do my suggested best practice before you go on and do any configuration and start chasing your tail. What do I always recommend you guys do at this point is give the host name to all of the devices, enable any ports, no shutdown any router ports, and check with Cisco Discovery Protocol, CDP, to make sure the wiring is correct. Okay, so I'm going to jump back to the router. Notice the wires are still red on the router ports because nothing has been shut down yet. All right, so R1 has already been given a host name. I'm simply going to jump ahead and do these steps in advance. All I'm going to do is do a no shutdown on the Ethernet ports on the router. So configure terminal. Am I allowed to do this interface range? Gigabit 0/0/0/0-1. Oh, good. No shutdown. I can do it. That's a quick and dirty trick there. It works on routers as well as switches. Okay, I'll go to the second router and do the same thing. Configure terminal. Oops. Configure terminal. Interface range. Gigabit 0/0/0-1. Do no shutdown. So I'm currently at R2, and it'll take a second for CDP to work here. So if I do a show CDP neighbor, oh, let me expand the scope of this thing here a little bit. It's chopping off. I made the font so big. There we go. That's a little better. I'll repeat the command. It didn't take long to do this. So R1, we're at R2, and the chart is showing us that R1 is his neighbor through R2's G00 port goes to R2's G00 port. Yeah, that's what it's supposed to be. Even tells us this is a 4300 series router. And by the way, R2 is also connected directly to S2. Okay. So let's go to, I can see from R2, I can see my neighbor switch 2, I can see my neighbor R1. Let's go to switch 1 and see if his neighbors are proper. And that will prove the whole thing's cool, copacetic. Show CDP neighbor. Again, he's wrapping a little bit. Let me unwrap him here a little bit. There we go. So from the standpoint of switch S1, I should see my router R1 at the top. And yes, my fast ether port 5 of my switch, switch 1's port 0/5 goes to the G001 port of the router, R1, that's proper. And switch 2 is connected to this neighbor switch from port 4 to port 4. So our wiring is good. Okay, it's easy to see here in Packet Tracer that the wires are in the right places. When you're here physically in the lab, it's sometimes a little tricky because there's a mess of wires back here and it's hard to see. So that's just a suggested best practice that I suggest you guys do for this. Okay, now we're going to go back to R1. I'm at the bottom, I'm below the gray bar on the lower half of page 5, and we're going to configure addresses for both routers. Now again, I'm not going to do the IPv6 here in the devilishly difficult to type in IPv6 addresses. Just to save a little time here in the demonstration, I'll do the IPv4 part, and then you guys do the IPv6 part as well. However, look at that. Part 2, step 1A. It's a very important command. If you ever considering doing any type of IPv6 addressing on a router at all, type this command first, IPv6 unicast routing, because otherwise it won't do any static or dynamic routing of any type between the different devices. On the switches, the problem was slightly different. On our older switches, they didn't support IP version 6 at all. In the switches that we have in our lab, the newer 2960 switches, yeah, they will support IP version 6, but you got to do that, change that switch database manager, SDM, and reboot the switch, dual, make it default dual, so it can support that. But in this case, the switches are being a pass-through devices. You don't have to do anything to the switches at all. You could replace them with a piece of wire, and it will work just as good for this particular lab. Okay, so I'm going to go to router 1 and router 2, and I'm not going to do the IPv6 unicast routing because we're not going to do that right now. Okay, so R1, I'm going to go to interface, go to the config mode, and let's go to interface G0/0/0. You guys here in the physical lab, G0/0 only. If you type G0/0/0, he'll come back and say, I don't have any interfaces with that numbering scheme. That's why I like the command show IP interface brief. When you first put your hands on the device, type show IP interface brief or show prot, and it'll immediately tell you what I call the interface port numbering scheme. So you can see, some of the older routers were, F0. Later routers F0/0, G0/0, and the newer, more current routers are, probably 10 years from now, they'd be G0/0/0/0/1. Who knows? They'll run out of numbers. Okay, we're supposed to give this guy, I'm near the bottom of page 5, and I'm going to give him an IP address of 172.16.1.1 and a /24 mask. I'm going to skip the IPv6 stuff. We've already done the no shutdown. So now to go to E0/0/1. He's getting an IP address of 192.168.1.1.255.255. No host machines in this lab, no VMs. Sorry, we haven't got our VM fixed yet, but fortunately, this last lab, we don't need it. We're going to get the new license code, and we're going to update the VMs in here so that, because when we come back after our 2 weeks from now, when this class continues and when the Cisco 1 class starts, we need those VMs that Thursday right away. Okay, now we're going to configure on R1. Let's just check here, just to touch base here. I'm going to do a show IP interface brief, and we can quickly see that. Let me expand this a little bit. He's wrapping. We can see that did we assign the proper addresses here? Just checking my chart on the front page. R1 is supposed to be 172.16.1.1, and G001 is 1. Okay, that looks good. Looks good. Now, the problem with show IP interface brief, it doesn't show you the subnet mask. So I like to command show protocols. It shows you the IP address and the slash number. And it's not so confusing. If you type show interfaces, you can look at them one by one and you get a page of all the errors and stuff. Show prod for short. Very cool command to show you the slash numbers as well. So I think I've got those numbers correct. And now we're directed to, I'm on top of page 6, we're going to create some loopback ports. Because this lab is static rather, we want to prove connectivity between different devices. So we're going to add some more networks in here. So the loopback port is like the 127.0.0.1 on your desktop PC. It's always active. You can ping 127.0.0.1. If you install a web browser like Microsoft Internet Information Services or the Linux type things that you can run, you can always point your web browser to 127.0.0.1 and check your web server that's running on your particular individual machine. Okay, I'm at R1 still. Yeah, I'm at R1. I'm going to create some loopback addresses here. And again, I'm just going to do the IP version 4.1. So configuration mode, interface, loopback 1. Loopback ports do not have to be shut down. They are born alive. They are born up and up. You can shut them down if you want to later and do a no shutdown later if you want to. But they're up and up automatically. You don't have to do the no shutdown. You can type no shutdown. It won't hurt. They're already not shut down. They're already in the enabled state. Okay, IP address is supposed to be 10.1.0.1. He gives the no shutdown command. We don't have to do it. We'll test that to prove that, but that's just, he did that for insurance. Okay, so interface loopback 2. And his IP address is given here as 209.165.200.225, which looks like a public, graphically unique public internet address. It's not the 10 dot, it's not the 172.16, it's not the 192.168. It's a special reserved address for training and documentation. It doesn't exist on the real internet. It looks like a real internet address. So in the Cisco Network and Academy labs, when they have like an external server, typically they'll make it 209.165. So it looks like if you're doing network address translation or something to an outside address, you can use that for your fake address. And look at that weird subnet mask, 255.255.255.224. Now let's check and see. If I do a show protocols here, everything will look like it's up and up, right? Let's do the more familiar command, show IP interface brief. Everything's up and up. Okay. The addresses, did I do the addresses correctly? Did I just check on the first 10.1.0.1 is loopback 1, loopback 2 is 209.165.200.225/27. Matches the front page of the lab. Good deal. We can go on here. Now let's do the same thing on R2. Stretch the printout a little bit so it's easy to read. So on R2, we're going to go to the configuration mode and say interface gigabit 0/0/0. You guys in here will be just the 2 zeros, not the 3 zeros. IP address 72.16.1.2/24. We already did the no shutdown. Interface G0/0/1. Oops. Oh, I fat fingered it. Oh dear. Interface G0/0/0. IP address 172.16.1.2. Okay, interface G001. IP address of him is 192.168.1.2. We should not have to do the shutdown. Okay, interface loopback 1. IP address 10.2.0.1. Interface loopback 2. IP address 209.165.200.193. 200.193. Back to 255.255.255.224, the /27. Okay, show IP interface brief. Is this all correct? Let's see. 192.116.1.2. This chart was so big it went to 2 pages. G001 is supposed to be 192.168.1.2. It is. It's up and up. Loopback 1 is 10.2.0.1. And loopback 2 is 209.165.200.193. Are our subnet masks correct? We'll do show prot. And they should all be /24s except loopback 2. He should be /27. He is. Okay. Okay, so at the bottom of page 6, they do a show IP interface brief on both devices. Make sure that they're correct. Save your configuration. So I'll do, by the way, the write shorthand command, WR, write short for write mem, is the old deprecated version, iOS version 9 command, which is equivalent to copy run start. And you'll have to press enter twice. And I'll do a write on the first one as well. Our configuration is saved. Okay, down at the bottom of page 7, we're going to go and do some static and default routing. So we're going to go to R1 and configure a static route to R2's loopback network. Because right now, let's look at show IP route, and let's look at R1, what he knows about. He knows about all his directly connected interfaces. He's got 2 loopback ports, and he's got 2 directly connected Ethernet ports, and he knows about those. R1 has no knowledge of R2's loopback ports. He would not be able to ping them. He'd be able to ping R2's G000 port is directly connected to it. He'll be able to ping his G001 port through those loopback through the switch, but he doesn't know, not loopback through the connection that's through the switch, but he doesn't know the loopback. So we have to add some static commands to do this. Okay, in the chapter about static routes, we talked about static routes and default static routes. So there's a couple ways to do this. If it's a simple network, you can just simply put in, here we are at South Campus. We need a connection back to the Trinity River, and they've got the connection to the internet. We're a stub network. Let's just put in a default static route to go back to the home network, Trinity River downtown, and they'll give us connectivity, everything. Very simple. If you have a more complex network, you have to use individual static routes. So overwhelmingly in the real world, we're going to use dynamic routing protocols, like we use, the campus uses, TCC uses OSPF. We used to use EIGRP, now we use OSPF. And that will dynamically share all the networks, all our campuses with all the other networks, and you can go connect and ping to any other device on any TCC facility. We want to define a static route back to Trinity River, and it would be too cumbersome to put in lots of individual static routes, default static routes on all the routers. So instead, we're going to use OSPF, which is a dynamic routing protocol that sends network information to the OSPF routers that is dynamically learned, and we're going to give OSPF one single additional job. Please propagate this default static route to all the other routers. And we'll create it on that one router in the entire network, which is actually connected to the internet, which is down at our data center at Trinity River somewhere. So that has a default static route created, and then we're going to propagate that to all the routers, and they'll show up on that. But we're not using dynamic routing protocols today, so we're going to manually create all these routes. Okay, so I'm at the top. Nothing confusing about all that, huh? Page 8. We're at the top of page 8. I'm going to configure a static route so that we can reach R2's loopback network. So I'm at R1 prompt. I'll go to the global configuration mode, and I'll say IP route n.2.0.0, which is the network I wish to get to, which has a subnet mask of 255.255.0. How do I get there? Well, let's see. If this is a serial port, I could do the exit interface. But Ethernet, you can't do that, because Ethernet is a multi-access network, and an exit to what other? I could be 10 other devices. So we're going to use the next hop version. Got to do it with Ethernet. Unfortunately, it requires a recursive lookup in the routing table. He's got to go back to the routing table and look up that 192.168.1.2 address, and he's got to go back to the routing table and resolve that. So if we do show the IP route, we have a static route, the S line about 3 lines down. How do I get to the network 10.2.0.0? I'll do a next hop to 192.168.1.2. How the heck do I get to 192.168? I got to go through a recursive lookup now and look up the 192.168.1 network. Oh, so it goes up my gigabit 001 port. So that's how he has to resolve it. Double work for the router. Okay, anything we can do to reduce the load on the router by reducing the number of times it's got to look at the routing table, anything we can do to the router to reduce the lines on the routing table is going to improve the performance of the router. Think of the poor job that all these internet service provider routers have got. They have over 750,000 routes to the backbone of the internet. They got to look through every time, every single packet that comes from your, when you're playing the game, they got to look through 750,000 lines. So they have to be super fast processors. Okay, ramp mode off. Okay, now on R1, we're going to configure a static default route. Still in the global configuration mode, IP route. Okay, static default routes. Okay, in the DOS world, you guys, you DOS guys, you PC, what do they call it, A+ guys. I'm going to go to the DOS prompt. I'm going to type delete star.star. What's that going to do? What does star.star mean? It means erase all the files, delete all the files. So I don't have to type 200 file names by hand individually. That's a wildcard. In IP networking, the wildcard is 0.0.0.0. It matches any address. It's like delete star.star matches any file. 0.0.0.0 matches any address. So we're going to create a default static route. We have our individual routes within our corporation. Those are specifically in the routing table, the 172.16, the 192.168. That's in the table. What about when you go to the internet and it's an internet global site? Okay, those won't be in our routing table. We don't want 750,000 routes in our little bitty branch office routers. They don't have the capability for it. So we're going to create one extra line in the routing table as default static route, and that will point back to Trinity River where the connection to the internet is. So 0.0.0.0 is any IP address with any subnet mask. And how do we get there? In the old days, we'd point to our serial port. Well, we're getting rid of the serial ports now because everyone's gone to Metropolitan Ethernet or MPLS or these types of techniques where we're fiber optic connected with Ethernet. So I'm going to do my next hop address at 172. Oh dear, next hop, recursive lookup, but we have to tolerate it. Now we're going to create a floating static route. A floating static route is one with a higher metric. By default, a static route has a very low metric, 0, 1, which means the lower the number, the more desirable it is. A floating static route is a backup route. We have a loop topology. What if one of those lines got cut? By number one enemy of fiber optic cable, backhoes. They tore the building down out here and they managed to not cut any fiber optic lines. I don't know how they did that. So if one of these lines got cut, we have backup routes. We can go the other way. It may be more latency. Maybe we'll go through more devices, but we have a backup route. But we got to configure this. So I'm going to configure the floating static route, and it's going to be 0, 0, 0, 0, 0, 0, 0, 0. And the floating static route is 192.168.1.2 with a metric of 80. That's higher. It will not be in the routing table unless the main route goes. We're going to make it fail. We're going to do a step here and make it fail. Okay, step 4, we're supposed to go to our router R2 and we'll create our static default route. Oops, from the configuration mode. IP route, quad 0. And what's our next hop? 172.16.1.1. Standard metric, 1 or 0, most desirable route. Now, we're instructed to go back to R1 and show the routing table. So we have our standard default, we have our static route we created, and then we have our default route. How can you tell a default route has been created? At the top of the routing table, it will say gateway of last resort is, and that's the default static route. Before you create it, it looks like this. I'm going to go to, oh, I already did on R2. It's going to show us still. Okay, if you have not yet created a default static route on the router, that will say gateway of last resort has not been set, but it's been set now. We did that command. Here's our static default route. S for static. Asterisk means it's the default static route. This is the one that normally you're going to run a dynamic routing protocol within your corporation, RIP, OSPF, ERGRP, whatever you choose to do. But so you don't have to have 750,000 routes to the backbone of the routing table and all your cheap little $500 branch office routers. We're going to create a single static route back to our service provider, or in the case of us, it goes back to the home office. And that way we'll connect. If it had been done through OSPF, like we do, it would say OEX2. OSPF propagated the external type 2 route as a default static route to all the other routing tables. And on the printout on the bottom of page 8, it shows the S at the top. On our packet tracer, it shows at the bottom, but they're all in the routing table, so it doesn't matter. Now, okay, is this going to work? I haven't tried this yet on packet tracer. Is this going to work? I'm at the top of page 9, and we're going to execute the trace. Before I trace it, I'm going to try to ping it, just to make sure it's a sanity check. Okay, the first dot, ARP had to line up to layer 2, MAC addresses, layer 3, IP addresses, and then it worked fine. I'll do it again. ARP is retained in memory for maybe 3 minutes. So if I don't keep doing stuff, you should remember this. So we have IP connectivity. Now let's do the trace. 2.10.2.0.1, and that'll show us all the routers in the middle. He showed us that 192.16.1.2 was the one that was in the middle, the pathway we went to. Now, on R1, we're supposed to trace to 209.165.200.193. I didn't ping it first. Let's see, control Z6, in a loop. Control Shift X6. When I'm breaking out of it. 209.165.200.193 is present on. Isn't that present on R2? Let's check R2. .165.200.193 is up. Everything's up and up. Everything's up and up. I'll try pinging it after this thing times out. What we're supposed to do here between step C and D on page 9 is we're going to shut down one of the ports on R1, and that's going to remove our more desirable path, less latency for your hops, and it should go back through the other way. Shift 6X. There we go. I finally got it. Okay, let's try pinging that address. What was wrong with it? 209. Did I mistype it? 209.165. Oh, I mistyped it. 200.193. Okay, ping is okay. No, I must have mistyped it. Now we're going to trace to 209.165.200.183. Okay, and that matches the print in the lab. Now we're going to go to R1. Are we on R1 still? We're on R1, and we're going to shut down. We're going to shut down that gigabit 000 port, which is the pathway between R1 and R2, the most direct pathway, the core route. But he still has an alternate path for the switches. He should still be able to connect, but it'll be more hops. So we'll go to the configuration mode, interface gigabit 0/0/0, and do a shutdown. I mistyped it. Interface gigabit 0/0/0, shutdown. Permit shutdown. It is administratively shut down. Show protocol. Permits administratively shut down. Okay, so it tells us to type this new command that we haven't done before yet. Show IP route static. It's kind of like show IP route, but it only shows you the static entries. And you can see that old default route we had, it was S star on the 10.2, which had an administrative distance of 1. Now it's starred to the new. It's a default static route 0/0/0/0 with a administrative distance of 80, which is kind of undesirable, but the 0 has gone away. We did a shutdown on it. So now that's our alternate path to get back through there. So now I should be able to type a trace route. Oh, that's that same one. I should be able to do up arrow and do it. Oops. And now it's going the alternate way. Okay, we're supposed to go back now. Interface gigabit 0/0/0, and doing no shutdown. Bring it back in. Okay, and part 4 is the IPv6 stuff, and I'm not going to demonstrate that here in the lab. Okay, so as a reminder, you guys that listen online, watching the recorded presentation, you guys are in the lab. So we're in the last week of class now. The final exam period for the first 8-week mini-term session started yesterday, and we'll go through next Wednesday at 5 p.m. You have until Wednesday, next Wednesday, a week from yesterday at 5 p.m. to complete the 5 module exams on Network Academy, the final exam, and that's 50% of your grade, and complete all these labs. That's the other 50% of your grade. So if you need to complete any labs, you can do those remotely via packet tracer, and then send me the Microsoft Word documentation that you put any answers into. Some of these didn't have answers, I know. Just put it's like SAT, 200 points for putting your name on it. And then we're going to go right into, after next Wednesday will be the deadline. I'll submit the grades to my TCC Blackboard and WebAdvisor. You guys will get your final grades. And some of you guys are coming back in the next 8 weeks for the 4 course. That will start just the same. We'll do exactly the same thing we are doing now. I will have an online session at 9 o'clock every Tuesday, recorded for later presentation. Okay, so you can come on, watch it live. You can watch it later. You can do anything you want to like that. And then on Thursdays, we'll have labs. I'll always do a walkthrough demonstration of the lab here in the classroom and record that. A couple people don't want to ever come to the labs. They want to do it from home because they're scared. And they can watch it there. You can watch it there and review that yourself. Okay, let's see. Let's stop recording.